When we program, the information we provide to the computer is referred to as data. The first of our basic data types are numbers, including integers, for example 3 or minus 111. Real numbers or decimal numbers which have a floating decimal point are called floats, such as 9.81. Complex numbers are also catered for, and here j is assigned to be the square root of -1, which is an imaginary number. Besides numbers, we also have strings, which resemble words. Each string is comprised of elements or letters, and they're defined using quotation marks, such as name and surname, or even a space, which is an empty character. The next data type may be slightly less familiar to you. This is a Boolean data type, which can be either true or false. For example, we can test whether the variable name equals Mark by calling the bool function, which evaluates the name equals Mark as true or false, and in this case it returns true. Before moving on, let's practice with these basic data types. Here we have a Jupyter notebook, and in the first cell we'll practice with the basic numerical data types, starting with integers. Here we've got an integer data 3. When you assign variables in Python, in this case the number 3 is stored in memory, and a variable name a points towards that location in memory. So the assignment of variables is relatively symbolic in the sense that the data itself, the numbers, are stored in memory, and the variable names point towards that location in the computer's memory where that data is stored. So here we've created 4 objects in memory, and the variable names point towards these locations in memory. As you define these variables in memory, the variable names enter the namespace. You can provide an overview of this namespace in Python with the command whos, which prints out what variables are being defined in memory, what type, and in some cases, how much memory these variables are using. Creating string data types is relatively similar. In this case, instead of numerical data, we have characters for letters or symbols. And again, as with numbers, our human readable data is converted to binary data forms and is stored in the computer's memory. With strings, we can join them or concatenate them together using the plus operator. And here we'll create a variable called full, which contains the surname, first name, and a space between them. Again, calling the function whos should show us that these new string variables have been added to memory. Next, let's practice with a simple Boolean example. And here we'll use the function bool to evaluate whether a statement is true or false. Here we'll assign a variable b to our very obvious statement, is 1 equal to 1? And yes, it is. And in our next example, we can show that we can easily combine the print statement and the Boolean function statement in one line, so we can test, for example, is our variable n equal to 2? And no, it's not, it's false. N was defined as equal to 3. And if we experiment, we can also test if g is 9.81, and yes, it is. It's true. So it's a very simple function, and you'll find a place for it in solving different problems when you want to check the value of a variable and act on whether that variable is true or false. It is very easy to convert data types from one type to another. In Python, we've got 3 basic functions, int, float, and string, to do precisely that. We can also list what variables we have by stating the type of the variable, and as we've seen earlier, what variables we have stored in memory using whos. So a whos example again shows us the full number of data types stored in memory. Here we can see there's a collection of strings, integers, floats, a Boolean, and even a complex number. To practice conversions, let's call our first conversion function. Here we are going to convert our integer n to a float, k. Now we can print this conversion, and we should expect a decimal point has been added to the integer. And yes, it has. So our integer 3 is now converted to a floating point number 3.0. So these conversions are very straightforward. And again, there may be moments when you're solving a programming problem where you'll need to convert integers to floats or floats to integers. If we try to convert a string, like name or full, to a float or an integer, we're going to have an error. Could not convert string to float. So our error message is very, very clear in this case. However, if the string looks like a number, Python will successfully interpret it and convert it to an integer or float on request. For example, if we say our variable n is equal to a string 4.2, since it's numerical like, this string should be converted successfully to either a float or an integer. Let's test this out by creating a variable m, which is going to be equal to the string n converted to a float. And then we'll print out the value of m, and it's successful. With these basic data types, we can start performing some basic operations, such as simple arithmetic, including addition, subtraction, and multiplication, together with some less well-known operations, including integer division, float division, and the remainder operation. The symbols for these operations are relatively straightforward. Multiplication is a star symbol, remainder is a percentage symbol, and power is a double star symbol. Take note that both integer division and remainder return an integer. Let's look at a few examples. Firstly, we'll define two integer data types, I and j. Next, we'll practice with the float division. And with the float division, we should expect an answer that I divided by j is equal to 6.66 recurring. Let's compare this with integer division, which uses a second forward slash. And here, we shouldn't expect a fractional remainder. Indeed, integer division in this case returns 6. Next, the remainder operation is similar to integer division. Here in our example, we'll have the remainder of I divided by j, or 20 divided by 3. And of course, the remainder of this is 2. After these numerical operations, let's have a look at some basic string operations. First, you can add multiple strings together using concatenation. It is also possible to multiply a string by an integer. And since a string is a sequence of elements comprised of letters or symbols, you can also use the length function to return how long or how many elements the string has. And you can index the position of these elements using square brackets with an integer. Let's look at some simple examples with string operations. Firstly, we'll define some simple strings for name and surname. And also a space. The idea here is that we can concatenate or join up these strings into a full name variable comprised of first name, a space, and then the surname. Once we print this out, we can see that we now have a new string called full, comprised of all three initial strings. Next, let's see an example of string multiplication. Bear in mind that the multiplier here needs to be an integer. You'll get an error if it's a float. After that, we can show that the length of the string has so many characters using the length function. And we can index the first character as index 0 in a square bracket. And we can define a new variable for our initials. Indexing is a topic that we'll cover in advanced data types in a future lecture. But for now, we can show a very simple example of indexing from the first character or element, which is index 0. And we can cycle up from 0, 1, 2, 3, and on and on. However, if our index exceeds the maximum index of that string, we'll get an index out of range error. With strings, we can also slice or select a subset of the string. Here we've got the first 3 characters from 0, 1, 2. And we can also define not just the beginning character, but the end character using the index -1. Besides the typical arithmetic operators, we can also look at assignment operators. The basic assignment operator is equals, which assigns the value on the right to the variable on the left. The other assignment operators shown here are essentially shorthand versions of plus, minus, multiplication, and so on. They enable us to do the same programming operations with fewer symbols, and this encourages fewer bugs to occur. With your operations of numbers and so on, you have to remember that basic precedence, or the order in which the operations occur, are defined by basic mathematics. So for example, multiplication and division have precedence or come before subtraction or addition. And if it's an equal precedence, so if you've got multiplication and division next to one another, the precedence then is from left to right. So whichever operation comes first, that takes precedence. As with normal calculations, you can utilize brackets to control the precedence and enable you to carry out your calculations. So it's very worthwhile doing a quick practice of these assignment operators to appreciate their utility. In summary, in this video lecture, we've had an introduction to the basic data types, which begin with the numerical types of the integer, the float, complex numbers. Next, we've got strings of characters and Boolean data types of true and false. We've had a number of new functions, such as the conversion functions for the data types, together with type, whose, which gives us information on the data type and indeed can give us an overview of the data types we have in memory. Also take note of the new programming jargon from operators, modulus for remainder, expressions, concatenation, indexing, slicing, and finally precedence.